Hello, everyone, and welcome to this month's Rancher Online Meetup. This is Shannon Williams with Rancher Labs. It's great to see so many of you here today. I'm very excited about today's topic. We have a good one. We're going to be talking today about monitoring and diving into the brand new Prometheus support that we announced last week at KubeCon and will be is already available if you download the latest alpha build of Rancher. So again, for anyone who doesn't know me, I am Shannon. I'm one of the founders here at Rancher and run all of our sales and marketing and customer related things. I'm usually joined on this meetup by my co-founder Darren, who's our chief architect, but Darren is out today. But I'm lucky to have two other awesome people on the meetup with me. Bill Maxwell, who has joined me for a few of these over the years. For any of you who attend regularly will probably know Bill. Bill is the DevOps lead here at Rancher, and Bill is going to be really demoing a lot of the new functionality in the Rancher 2.2 product and the new Prometheus support. Bill, you want to say hello? Oh, maybe you're muted.
Hey,
there you go.
Yep. How's it going?
And then the other person joining me is Jason Van Brackel, a senior solutions architect. Jason is in Philadelphia, unlike Bill, who's in sunny Arizona. But Jason is going to be really talking a little bit more about the practical approach to using container monitoring tools like Prometheus. I'm really going to talk about the metrics that are critical and how to build a monitoring strategy. Jason, are you unmuted and want to say hi? Jason? Oh, I can't hear Jason, so hopefully he'll figure out his unmute before it's time to get going. Jason, let me know if you're having any technical problems. All right, well, with that, I do want to kind of just, for anyone who's new to our online meetup, I just want to kind of introduce the idea and explain what we're trying to do. So this is a meetup. It's not a webinar. It's not a kind of a one-directional conversation. We really focus in these monthly gatherings on having kind of a deep discussion about a topic. So we don't set a time limit. For all of you who who've only got an hour blocked, we will try to get through quite a bit in the first hour, but I guarantee we won't be done. We answer lots of questions. We have lots of discussion about things. We demo lots of things. That means we really don't know how long these take until we do them. Some go for an hour and 30 minutes. Some go for 2 hours. Occasionally, we're still on 2 hours plus later answering questions. So questions are always welcome. This is an opportunity to talk to people who are working on this stuff all the time. And if you have questions, we will certainly answer them. We will, for the most part, focus on questions as they come in that are relevant to the topics we're talking about at first. And if you're asking a question about something related to Rancher, Docker, Kubernetes, or containers in any other context, we may just respond to you in text, or we may not even be able to get to it till the end of the session. So please don't get frustrated if we don't answer your question right away. We do get literally hundreds and hundreds and hundreds of questions on these sessions. So please keep them coming. There's no bad questions. We do respond to them generally in public, unless you mention that there's a private question and you work the word private. We often respond to all, which means you might ask a question and we'll write the response. Then everyone can see both your question and our response. So if you have a question that you don't want to be responded to, I'll just type the word private at the beginning, and we won't mention it out loud. We won't read it out loud. We won't respond to it. The other thing is we demo everything live here. There's no recordings. This is not we're not faking anything. It's live demos. Occasionally things don't go well and things break. So please be patient. We usually try to have a secondary option in the back burner, but it's technology. So sometimes things don't go the way we expect them to. Well, lastly, in answer to the most common question we get, this meetup is being recorded. It will post in the next day or two to YouTube. We send out an email with the link to everyone who attended, so you can share it with other people. You can watch it again, and you can see from here that it's more common than not actually that we go over 2 hours. If you look at these recording times, we often get into long discussions about things that, especially at the end, often the main content ends and then we continue to take questions with people who who have maybe questions on other topics, storage or networking or something Rancher related. We do have a Slack channel that we use to talk about this. So if you are in the Rancher user Slack, slack.rancher.io, I think is the URL you need to go to get an account. There's a whole Slack channel called Online Meetup. You can chat with people there if you want to have a more live discussion. But we do also talk on Twitter. So if you have questions afterwards, if you just hashtag it at Rancher Meetup or send it to me at SMW355. Please post your picture. Tell us who you are and what you're doing while you watch the meetup. Show us a picture of your cute kid. Show us where you live and what you're doing. Introduce yourself. We'll stick you up here on our wall of friends, and we'll get to know you. So please, tag Rancher Meetup in your conversations or use the online Slack channel. Okay, with that, let's get into the meat of things. The last thing is if you want to ask questions, the question pane is part of the GoToWebinar console over on the thing. Just push it out, hit question, and you can type up your questions in there. Okay, so I will have a really fast 2-slide overview of who Rancher is and what it does, and for anyone who's not familiar or maybe this is their first time. Then we're going to dive into the meat. Jason is going to start us off. He's going to go through this, kind of a little bit more of a strategic overview of best practices for building a container monitoring strategy. We'll talk a little bit about, how things change as you move to more microservices style monitoring. Then Bill is going to introduce the new Prometheus support we were released last week, show you how it works, demo it, get hands-on. I think he's going to be spinning up a Minio environment and using that to throw some stats. We'll be looking at Grafana. We'll be looking at kind of time series data and talking it all through. And then I'll wrap us up just talking about next steps. If you've got ideas for future meetups or you'd like to present a topic, by all means, either direct message me or throw it in a question and I'll see it. But we'll get to some of that at the very end. So with that, I'll start by just giving a really quick overview of Rancher. For those of you who aren't familiar with us, Rancher is a software company. We make open source software. Rancher is an open source product that we make. The company's called Rancher Labs, but the product's called Rancher. And it is a wildly popular open source management product for building a Kubernetes platform. And what that means is it allows you to deploy and manage Kubernetes clusters anywhere, and including existing Kubernetes clusters, and provides a lot of the frameworks necessary to plug that into your existing IT system. So, connect it to your identity management and RBAC system, set up your security policy, deploy all of your, connect it to your logging and monitoring solutions, and provide really Kubernetes as a service, a container service. We do it all as open source software. There's no enterprise version or magic version. We pay our bills by selling support services for companies that put this in production and need it supported. But that's hundreds of customers that use our support services, whereas the number of Rancher users is well over 20,000 on any given day. So the vast majority of people use the open source version for free and contribute back with questions, participate in the open source Slack channel to talk about any issues they're having, or use our forums to post questions, post issues on GitHub. So it's a very robust and lively open source community. The thing that makes Rancher really, I think, compelling for a lot of teams is it kind of brings together the requirements of an IT organization that wants to deploy Kubernetes or operate Kubernetes as a cloud service or consume Kubernetes from the cloud, and cares about the compliance and the policy management and capacity management and delivering kind of shared services for their organization. Rancher does really excellent multi-cluster management, federated policy management, so you can define things and push them out, with a really rich set of rich experience for the actual user of Kubernetes. Rancher, just when we deploy Kubernetes ourselves using RKE or we're setting up an upstream Kubernetes implementation, but we give you the choice of also deploying hosted Kubernetes like EKS on Amazon or GKE in Google, or even importing existing Kubernetes clusters you might have built any other way, and then centralizing all of your management and providing a really rich set of tools that make it easy for teams to implement their applications on Kubernetes. So, today we're going to be talking about how Prometheus is now, part of that tool chain, and how you can easily turn on Prometheus and use it as a service within your cluster. We do the same thing for, alerting and logging, for CI/CD, for Helm, and for a lot of the other services around how users kind of consume Kubernetes and use it. So if Kubernetes is an amazing engine, Rancher is kind of a car, and it's an open source one that anybody can use. So it just makes the experience of using Kubernetes really fantastic and awesome for users. So that's really Rancher in a nutshell. If you need more information, we have lots of demos and trainings and other things that will provide a deep dive on Rancher. If you go to our website, we run a training every week that kind of does a really good hands-on overview of what it does. It's live like this and answers all of your questions. So if you've never taken that, we have hundreds of people on there every week learning how to use Kubernetes and Rancher and Docker. So with that, we're going to talk about Prometheus. Time to move to monitoring. I love this picture. I was trying to find a fun picture to kind of summarize the idea of monitoring cattle, and I found that there are actually companies that make all sorts of tools for monitoring cattle. Unfortunately, they have low-res pictures, but I think you get the idea. And best of all, there's like a cowboy with a lasso with his iPad monitoring all these things with drones and satellites. So we don't have anything nearly that awesome. We're just going to talk about software, but it really is. It is the whole point of this is to provide you with a really good feel for what it takes to manage very distributed herds of containers. So I am going to turn it over now to Jason. Jason, if you've got your slides ready, I hope you've got your audio working now, because I couldn't hear you before.
Can you hear me now?
I can. You're on.
All right.
Okay. I am going to pass you the ball, and you should be the presenter now if you want to share your screen.
Absolutely.
I'll let you know when I can see it. Bingo. There you are.
Should be my GitHub?
Yeah, I can see your kids and you and your GitHub.
All right. So my name is Jason Van Brackel. I am Jason Van Brackel pretty much everywhere out on the web, be it GitHub or Twitter. So if you ever have any questions, feel free to reach out. I will warn you, though, if you follow me on Twitter, I'm a rabid Ravens fan on Sunday, and you'll just have to put up with that. I'm sorry. But that being said, also, if you're out on either the Kubernetes or Rancher Slack, I am at JVB. That's Juliet Victor Bravo. So let's get started. So today we're going to talk about monitoring fundamentals in Kubernetes, and monitoring fits into a greater conversation around introspection, essentially being able to observe one's own state and process. Yeah, usually if you were to Google the word introspection, you'll see a lot of information about self-rationalization, the psychology and human behavior, but it's so different in the Kubernetes field. It's the ability to see one's own state and process. And we're doing this at runtime, we're debugging and analyzing. We have, kubectl logs and kubectl top, and these give us the ability to see, state and process at time. The problem is that, kubectl top and kubectl logs just doesn't scale. So we need other ways to do that. And by and large, this is hard. It's hard because at the infrastructure level, we have multiple operating systems. Kubernetes doesn't just support Linux, but it supports many flavors of Linux, as well as Windows. And you're going to start having ARM operating systems and other things, including VMs as well, VMs as containers as well. They're often geographically dispersed. Your workloads may be in various data centers throughout the same region. They may be unreachable to you. You might be working with a provider like a GKE or EKS or AKS, where you don't own the control plane. You only own your workers. Or you may not be able to SSH into the box and have access because of regulatory controls and change control processes that prevent you from being able to see Docker logs, for example. And again, as Kubernetes evolves, we'll have various container runtimes. By and large, we're all still running on Docker Engine. That won't always be the case. Cryo is starting to gain some momentum. We're seeing Kata containers, this idea of running VMs as containers. Google recently released gvisor, which was the idea of having sandbox containers. But these all run under the covers as different container runtimes. So we don't even have a guarantee that we're always going to have Docker available to us. And then our hardware can vary, or our virtual hardware can vary. We may have GPUs, we may not have GPUs, we may have different versions of our operating systems. We might have Arch Linux versus Ubuntu Linux. We may have Rancher OS running in the picture as well. And like I said earlier, we're going to start seeing ARM devices and Edge IoT and all these things. And it makes introspection hard at an infrastructure level. Furthermore, workloads. We may not have knowledge of the location when they start up, whether the scheduler's in charge of that. They're various shapes, sizes, and behave differently. They have different resource requirements, and they also may rely on different container runtimes. Like I said, there will be a time where your workload will be requesting a specific runtime for features that are beyond just what we're running today in Docker Engine. So having the ability to do introspection on these things constantly is hard. And most important, scale. Scale can be huge. Right now we're working with customers that are everywhere from, I've got one Kubernetes cluster and 5 nodes, and that's all I need. And we're just containerizing our monoliths and moving our monoliths into microservices, and we're just getting used to this. But we also have customers that are already running tens, if not hundreds, of clusters, and tens to thousands of nodes. And these are the scale problems they're thinking about, and they're coming to it with, okay, how do I collect the ocean so I can boil it, so I can see problems, and so that I can find the problems before my customers find the problems. So introspection in Kubernetes boils down to 3 things: auditing, who did what, where, and when, for how long; logging, all the things our applications spit out, all the things that our CNI plugins spit out, all the things that our Kubernetes components spit out in structured and human readable ways. These are important. And then monitoring. What does my machine time series slice machine data look like on all of these things? So today we're going to be focusing specifically on monitoring. So I'm going to set aside auditing. I'm going to set aside logging. These things are important, and we'll probably talk about these at a later date, I'd imagine. All three from a DevOps standpoint are extremely important and vital to operating at scale. But today we're going to talk about monitoring specifically in Kubernetes. So from a Kubernetes standpoint, we're going to be talking about things that plug into the monitoring, the metrics API. So since 1.8, the idea of resource metrics has been around via the metrics API. It has its own API endpoint, just like everything else in Kubernetes, but it does require a metrics server to be installed. Metrics server is another component of Kubernetes, like the kube controller manager, like the cloud controller manager, like the scheduler. Metrics server is another one of these things. So metrics server itself is a cluster-wide aggregator for usage data, and it's a lightweight heapster. Heapster, for those of us who've been in Kubernetes for a while, was the old cluster aggregator. It's been around for a while. So if you were using Kubernetes prior to version 1.8 or even 1.8 and later, because these things are constantly evolving, you had cAdvisor and you had heapster. So if you look into the documentation around Kubernetes monitoring, you'll see cAdvisor. Anything before 1.8, you can actually pull up the cAdvisor via port 4196 on the kubelet. I may have that port wrong, but approximately. And it had its own HTTP endpoint as well on kubelet. That has since, has since been deprecated and then retired. And you can still use cAdvisor. It's a great piece of software, but it's still, it's hooked less and less into the Kubernetes binaries, and these things become more modularized. And Heapster was the same way. Heapster was an early attempt at cluster-wide aggregation of machine data as it pertained to Kubernetes. And there's a big discussion around monitoring Kubernetes and architecture, and it looks a little bit something like this. This is directly from the design proposal for architectural monitoring. Let me zoom in a little bit so you have a better look. So essentially, we're going to be talking about this blue area today. So you see over here on the left, we have our API server, we have kubectl top and the scheduler that both get data from the API server. Metrics server is doing the same thing, and it's aggregating data from the API server, from the nodes themselves, from the kubelet, and works alongside monitoring agents. So we're talking about that blue area today. So Heapster was in that blue area. cAdvisor was kind of a mix between the black and blue as it has changed. But you'll see over here we have the HPA controller for horizontal pod auto scaling, that ability to auto scale based on runtime behavior of the system being tracked by a monitor. And you notice here, while the HPA controller itself is black, it's a Kubernetes, part of the Kubernetes metrics flow. There can be HPA API adapters for custom metrics. So this gives you the ability not just to think about core metrics that Kubernetes is thinking about Kubernetes things, but also application-centric core metrics that allow you to expand out your pods as needed based on application-level knowledge. And this becomes really important as you're coming up with a monitoring strategy, for your Kubernetes cluster. So let's talk about some important metrics. And I'll break it down into control plane, etcd, worker nodes, and we'll talk about some generic things. Now, by and large, when you're thinking about metrics, especially at scale, you're less and less concerned with an individual time of data, right now view of the world. When we did N-tier and we had N-tier applications, we were dealing with stacks of servers together. At a scale, we'd have multiple stacks, or if we were sophisticated, we could spread out our services and our UIs across what we're now calling microservices, but weren't called that then. But by and large, we worried about nodes going down. We worried about our pets going down, and logs on those pets, and things that could be seen by an operator or a log parser in real time, and that pet was kept around. And now we're dealing with cattle and scale, and potentially elastic infrastructure, elastic application count, and elastic usage, which makes all of this harder. So from the Kubernetes control plane, we want to start looking for deltas on these things. So API response times, because we know that sometimes our system is under load and sometimes it's not. So the important thing is to first understand your system, understand how much resources it's using, but also understand have it hooked up so you know how long your workflows should take in your system. So from a control plane standpoint, start monitoring things like your API response time, how long your control plane is responding to requests, so you know that under light load, under heavy load, what it should be doing. And then as you see a delta or a change in that over time, that response time, if that starts getting longer and longer and longer, and you see your request rates going up on your Kubernetes API, that tells you that something's wrong. We don't know what's wrong, we know something is wrong. So you learn on those deltas. Then the control of the scheduler becomes really important. One metric is failed pods. So there are lots of reasons that pods can fail. Unbound persistent volume claim, you've run out of resources, maybe the node is just non-responsive and Kubernetes hasn't realized it yet. But scheduler failures, monitor that over time, change the scheduler failures. And also schedule preemptions. So in Kubernetes, preemption is when you start actually weighting which workloads get priority. A schedule preemption is where the scheduler says, you know what, I'm out of resources and I'm going to move you. You need to go away so that my higher priority pod can be scheduled here within the cluster. So you start seeing the preemption count go up. So ideally, you would have 0 failed pods, 0 preemptions, predictable response and request rates on your API to know you had a healthy control plane. So watching those numbers over time becomes important to make sure that your Kubernetes control plane is healthy. Let's talk about etcd. So your persistent store for Kubernetes. This is the brain of the entire operation. From a state standpoint. And there are two really big things here with etcd you want to watch. One is leader election or having no leader, because as we know, etcd has multiple nodes running on it. We want to make sure that it always has a leader, so somebody's in charge. But if nobody's in charge, nobody's doing anything. etcd's alive, but it's just sitting there. And then secondly, leader election. If we see the leader being constantly elected, it means that communication is timing out, that something has gone wrong and the master is no longer the master, and that communication flow can't go. So if you're constantly jumping leaders, there could be a network problem, there could be a multi-machine problem. If something along the communications of etcd between etcd's nodes, there could be a problem there. So those are important things to watch in the etcd world. And let's talk about all nodes, so all workers, essentially, all workers, all etcd nodes. all control planes, these are important for your nodes no matter what they're doing. CPU and disk utilization. If you're always at 100% CPU utilization, either you're really efficient, or you just have you're out of resources. It could be a little bit of either. So it's the deltas in CPU utilization become important. Disk utilization, disk I/O, disk read and write rates. How much are you talking to your disks, and specifically also capacity of those disks, because especially in your etcd nodes, disk running out of disk capacity is death. It really is. So being able to know, when you're healthy versus when you're at, 60%, 70%, 80%, 90%, to know that some action needs to be taken so you don't run out of space. Memory utilization. This becomes helpful for looking for leaks. Fortunately, the scheduler does a really good job of making, when you use resource limits, the scheduler does a really good job of making sure that you have enough space for your stuff and all of your stuff. But not all of your workloads are going to run constrained, and you're going to want to be able to watch memory utilization. Plus, you don't control all the things in Kubernetes. There could be a memory leak in a Kubernetes component. We all hope that's not the case. We all rely on that. But you don't trust the things you can't control. So you monitor the things you can't control, like the Kubernetes bits, to make sure that they're behaving. And that if you find they're not behaving, you go and you tell all of us, and we all go fix it, because that's what the community does. And then load average. Load average is interesting, and I really should have done some slides on this. But if you're not a Linux monitoring person, load average is essentially the amount of processes that are waiting for room on your system in 1 minute, 5 minute, 15-minute slices. And that load average, when it's healthy, should be at or less than your logical processor count. So if I have a single physical CPU with 8 virtual or eight logical CPUs, and I have a load average of 8 over 1 minute, 5 minute, 15 minutes or less, things are good. If I start seeing that, if I start seeing a double or triple, I know that I have a lot of contention for process space, and I know that there's a problem. So we monitor load average on your machines, because that means that processors are waiting around for time slices and not able to do their jobs effectively. And that becomes a really effective metric, even above CPU utilization, because you could be 100% utilized with a low load average. And so that would suggest you probably have a healthy system that is just fully ROI, and you're getting the most data resources possible. So workload metric guidelines. So let's talk about workloads. Generally, your workloads fall into one or two categories. One is your web workloads, your web UIs, your REST APIs. You want to be tracking essentially any 500s, any server errors on your HTTP are really important, because it means you have a service outage, you have a service problem. And then non-200 response counts. So you may have a certain number that you would expect to be, non-200, things like your 404s or 403s, that happen during only updates or things of that nature that might be acceptable level. But if you start seeing a whole lot of forbidden coming up, a 403, and you see a 403 count quickly, that delta just jump really quickly, that might suggest that somebody's trying to hit your system in things they're not allowed to see in an automated manner. So maybe even mean you're under attack. Or it just might be somebody is building, some developer is building out a process that they didn't think about auth and building out their process, and when they deployed it, it's just hammering your system with 403s. TCP and UDP workloads. So essentially anything that's not layer 7 is down layer 3 and 4. And packet loss is a big one. So packet loss can mean a lot of things. It could be high network volume. It could be there's a problem in your network. There's a problem in your CI in your CNI plugin. There's a lot of things in there. So packet loss is really important. I would even apply packet loss to applications that are HTTP based, because it really comes down to what's going on your network at the time, and a lot of things can affect that. And the other is a change of response times. This is why knowing your software and monitoring your software becomes so important, because you get to learn and know what an acceptable response is. And I won't use the term, I don't think KPI or SLA is necessarily important, though it might be contractually in your case. But having some sort of acceptable response time alert can become really important at scale, because that might be the first the first alert that something's wrong, even before your users start noticing. Yeah, I remember years ago I worked for an ISP. And there was a grammar school in the UK that was basically taking out all of the Delmarva Peninsula, so it's Delaware, Maryland, Virginia. And the first indicator that there was a problem, they were being DDoS to death. The first indicator that there was a problem was a change in response times when everything that was coming from the Delmarva Peninsula. They weren't watching for that, and by the time somebody noticed, all the ISPs on the Delmarva Peninsula were down. It was a fun day to work support because it was telling everyone, hey, I'm sorry you can't play EverQuest and search AOL. That's how long ago it was. But it's outside of our control. We're getting DDoS by the UK. And then custom metrics. These are application dependent. Again, as I said, I pay attention to any deltas from the norm. So know your software, know how fast it should behave for all of the various workflows. Treat those, set expected time frames around all the things your system does, and pay attention to any deltas from the norm. For example, let's say we're dealing with some sort of web storage mechanism, like a database or a file storage mechanism. You're going to want to know, reads per minute, writes per minute or per second, and then network packet. Those might be the three things that tell you how your database / file storage system is behaving. So those are application dependent. You may not have standard Kubernetes for that, but you might have the ability to instrument that from a custom metric that is readable by your metric system, that blue area from the architectural diagram from before. Any questions so far?
There have been lots of questions, Jason, but they're mostly kind of down into the technical side of how this is going to be implemented. So I think this has been great. I think you're covering a lot of the right things. One of the questions that Tyler asked was when it was about Windows systems, and you touched on it really briefly, but when you're monitoring those with Prometheus, is there an exporter for Windows that doesn't rely on remote WMI? He was saying that a lot of the companies they work with don't like turning that on due to security concerns.
Yep. Yeah, and that's the nice thing about Prometheus is that it can take both live data, things like WMI, but also take dumps. And I can certainly understand why you may not want to turn WMI on from an InfoSec standpoint, because it does give you a lot of instrumentation into the Windows system, the ability to affect the Windows system. And worked with that a little bit at a previous company. It's really hard to secure parts of that and not all of it. It doesn't have the same fine-grained RBAC system that Kubernetes has, for example. So great point. Also,
awesome.
Go ahead.
Another question Adam asked is when scheduling a service with an L7 load balancer on GKE, is it possible to specify the desired IP? I have a service deployed as a stateful set, but it doesn't need to be. I need to change settings on the deployment, so I simply want to change it to a workload. However, it's tied to a static reserve. That's probably a better one for later. Sorry, I thought that was about monitoring.
No problem at all. The L7, having done that a little bit, the L7 load balancer within GKE is completely separate from the Kubernetes piece itself. You can go into the network services and load balancing. You'll see the L7 load balancer. That may be able to be controlled independently from Kubernetes, but I'm not 100% sure as far as annotations, because there's a component called the Cloud Controller Manager that is the connection between Kubernetes and the cloud APIs, and their functionalities are provider centric. So you may have the ability to do that. It's one of those I should definitely check the docs on. I don't know that off the top of my head.
One other question. Kaushik said, will Prometheus be hosted on the Rancher cluster, and is it able to monitor other nodes on other Rancher cluster nodes? So, Kaushik, we're going to get into the architecture of that in just a minute. So if you just kind of hold that question, that's really what Bill's going to dive into as we wrap up. Once we're wrapped up sort of this overview and concepts around monitoring containers. So hold your question.
I've got 4 more slides, so we'll hand Bill the football in a moment.
Okay. All right, why don't you keep moving, okay?
Sounds good. So let's talk about Prometheus. It is an open source product. It was started by SoundCloud back in, I believe, 2012, and they were trying to solve that whole let's collect the ocean so we can boil it. It's now a CNCF project, and it deals with time series based machine data. It's not set up for logging or counting logs. You have things like Elasticsearch that are great at that. It deals specifically with time series based machine data. That's what it lives and breathes on. So it has a number of different components. It is a clustered technology like anything else. We talked about the jobs and exporters over there when they mentioned WI versus Windows, push gateway, and essentially everything ends up in some sort of database that can be read. But it hooks into Kubernetes, and under the covers, we've been using Alert Manager for a while to send to PagerDuty, email, Slack, and anything that does webhook. So we've been leveraging parts of Prometheus for quite a while, and now we're actually bringing full Prometheus and Grafana into the world. And as I mentioned earlier, Prometheus Web UI, API clients, and Grafana can all talk to that database through their Prometheus QL. And as I said, Prometheus is great with time series machine data. That's where it really shines. It's not meant for things like log aggregation and that kind of thing. There are other tools for that. And then Grafana, we saw Grafana over here in this little box on the right. Grafana, this is your visualization platform for time series data. It has open source and enterprise variants. It's Apache 2 on the open source side, just like Rancher. I also believe Prometheus is Apache 2. And it integrates with many time series database, where the important one for our conversation today is Prometheus, but it'll also talk to Elasticsearch and InfluxD and all kinds of other things, to make really cool dashboards. And that's the nice thing, is be able to do the analysis of what's going on in Kubernetes and in your workloads at runtime and over time, and be able to see those deltas over time. And that it also looks really cool, so that when your company makes it big, and they all talk about your great DevOps transformation, they interview you on YouTube, you have these awesome looking dashboards behind you. But that's it for me. Any other questions before I hand the football to Bill?
No, I think we're good. Jason, let's dive into it.
All right, Bill, it's all you.
Bill, you should be the presenter now.
All right. Okay.
And we can, and I can see your screen if you go to full screen mode.
Yep. Cool. So, yeah. So we're going to be just kind of what we're looking at here, just kind of going into the high-level overview. Rancher is, it builds out to be kind of a DevOps platform, and there's really a couple different, roles when operating kind of in a Rancher environment. There's the Kubernetes, the multi-cluster Kubernetes management, and so there's the the admin of Rancher, and they're sort of responsible for keeping Rancher server and its components up. But then there's the individual cluster operators, and their concerns around keeping Kubernetes up and running, making sure the components are writing, and just basic cluster health. Then there's the user space, the consumers of the Kubernetes clusters, and so really, as we've built out Rancher 2, we've focused on providing the solution so that it kind of we have to kind of cater to both use cases and sort of the access model around that. We're using all CNCF tools, but when it comes to deploying these things, you can absolutely do what we're doing. It's just how do you kind of do it in a self-service way, and that's where Rancher's really coming in kind of with the concept of the cluster level scope of things, and then the individual project level things, so that developers and users, application owners, and operators can have visibility into their applications and how things are performing. And so to accomplish that with the monitoring side of things, we've looked at leveraging great technology from the community, and so the Prometheus Operator, and so we're taking on that orchestration piece. As soon as a cluster is imported, we deploy the operator, and it's scoped in namespace, so that if you were to deploy the Prometheus Operator yourself, that still works. We're not trying to interfere with or get in the way with anyone using the tool directly. But really what that does is it deploys an operator, and it creates a bunch of CRDs, and then When you have those CRDs, you can use them to deploy things like a Prometheus instance. You can deploy it to watch service monitors and alerts. And so, what we're sort of doing now is we deploy a cluster level. You have the cluster level Prometheus that the cluster owner operator is sort of responsible for, and that is capable of scraping all of the Kubernetes endpoints, the nodes, anything that's sensitive. You don't want just an arbitrary application owner starting to scrape the various components of your cluster. That's sort of the purpose of the cluster level Prometheus. And then where we're going, the alpha preview is slightly different right now than what I think will ultimately ship. But where we're going is, then there'll be project level Prometheus, which will run in the user's project space, but it will be able to get metrics that are scraped from the cluster level Prometheus that are scoped only to the namespaces and projects, to that project's metrics and workloads. So what that ends up looking like when you're kind of at a high level, you have Rancher managing all your Kubernetes clusters, and then your cluster level Prometheus is monitoring your cluster level stats, your nodes, your Kubernetes endpoints, etcd, the various system components, and then each project has its own view of the world that's scoped specifically to the project itself. And so users are able to kind of get at that and scrape their own custom metrics as well. And that's sort of where a lot of the power comes in, and sort of what we're doing. I mean, out of the box, you get a good operation experience for running the cluster, but you, as a user who's deploying applications, you're able to leverage kind of the underlying platform in a pretty straightforward way. So right now at the cluster level, we're looking at etcd. We have to come up with a pretty good matrix. I don't have that yet. Of because we support Kubernetes from anywhere, depending on where you're getting it, we have access or visibility into certain components. On an RKE cluster that's provisioned by Rancher on one of our node drivers or a custom, we've got a lot of visibility. So we know where etcd is and how to communicate with it. We use the kube state metrics exporter, get the kubelet metrics, node exporter, and the ingress controllers. And when we've deployed those things, we're able to instrument and wire those things up pretty efficiently and get that data and present nice dashboards for you. When it's a managed solution like EKS, we don't have access to some of those components directly, so we can't measure it. But that's hopefully provided through your cloud provider. Project level, these are mostly workloads and metrics that are scoped to your namespaces in that project only, and then you're able to get custom metrics. At each level, you have access to Grafana to sort of visualize these. Components are, graphs are integrated for kind of high-level metrics at various points in the Rancher UI, which I'll show, but you can still, create dashboards with Grafana. And I don't like to do a lot of slides. I like to jump into demos. Let's kick that off.
Hey, Bill, before we jump into the demo, just a couple questions that I think are kind of interesting for this. One of them was from George. She said, how does Prometheus compare to something like New Relic? Is it similar? Is it more like Nagios, or more like a Datadog? Like, well, where would you put it in? Is it more application level monitoring or system level monitoring? Maybe you can just kind of answer that question a little bit.
All right. Yeah, maybe JVB, if you have some thoughts on this one too. But my experience, New Relic's more of an application performance monitor. It's an APM, so it's looking at the application itself, and it's able to kind of understand that the different programming languages and look at various subsystems to sort of get at certain types of data. With my understanding is without having to do a lot of instrumentation, you can still get some visibility. Prometheus is more of a scraper. It collects and aggregates data into databases and provides a really powerful search and querying language. It's still sort of left to the user to sort of provide and create those metrics. And I think Datadog and Sysdig and companies like that, they have their collectors, and so they have some fairly sophisticated tools around, kind of doing some auto stuff. But I think they also really support, like, if you have your own custom metrics and have instrumented, then also mixing that data.
Great. There's another question from Kaushik, and he said, if you wanted to monitor a node that wasn't part of Rancher, could you monitor it through the integrated Prometheus, or would it be better off to use just a traditional deployment of Prometheus?
Yeah, I think you can monitor endpoints that are outside the scope of the cluster. I haven't played with it, but I believe there's a way to do it by creating like a service type and then service monitor to monitor a service that would be like an external service. And I think ultimately it has to populate the endpoints for it.
Okay.
So maybe, I don't know off the top, but I think it's possible, maybe. But
okay. All right. Well, let's dive into the demo and see what we're looking at.
All right. So still see my screen, right? Okay. So I've got a pre-staged and a live demo cluster. So we'll build up a live demo cluster. So this is the standard Kubernetes cluster that's been provisioned with 4 nodes. These are all just custom nodes on Google Cloud. I have not enabled monitoring yet. So here's the stock dashboard that you get. And so in order to turn on monitoring, we come to the cluster level and we go to the new tools section and click on monitoring, and we enable Prometheus. Keep in mind, this is all in 2.2 Alpha 3, so you can download and play with all this. This is not a supported release. There will not be an upgrade path from this release. But if you're interested in checking out the feature and sort of looking at it, and again, we're also improving it and making some changes before what will actually ship. But a lot of, you can at least see where our head's at with this going forward. But there were some questions earlier on, so just wanted to let you know. So we're kind of using a embedded catalog app, and so with Prometheus at the cluster level, you can set a data retention. You can, we are going to deploy the node exporter that runs in host networking, so that is why the port is there. You can enable persistent storage, and if you've enabled a storage class, you can persist that data to a persistent volume, same for Grafana at the cluster level. Yeah, but we'll just, since this is a demo, we'll go with the ephemeral version. So here we're deploying Prometheus at the cluster level. And so to dive into that a bit and see what's going on, the system project, there's the cluster level view, and then there's the system project, which is sort of the cluster owner operator's primary workspace. So you can see we're deploying some catalog apps for that. Previously I installed Longhorn, that's not part of this, but we're deploying the monitoring components. And so you can have direct access to, I don't know which services are up yet, but we'll wait for this to go green. You can see we're deploying the Prometheus Operator, the cluster monitor for Nginx, the cluster level monitoring, Grafana, the node exporter, and we're just waiting for kubestate to deploy. And it just takes a second. Okay. So here's kind of what gets deployed into the cluster level. system project. And so now I can come into my catalog apps in the system project and see, here's the Grafana, and quickly go see the nodes. I don't really have much data yet, but that's starting to scrape. You can now get at the Prometheus dashboard itself, just to sort of look at what's going on with the targets. You can see all the endpoints that are getting scraped. So if you have to troubleshoot, you can kind of come look and see what's going on in here. Again, like, we're using the Prometheus operator, so a lot of the constructs, if you understand the concepts, if you look at the docs for the operator and understand those concepts, we're lightly orchestrating the Prometheus operator. One thing we are doing is actually putting an authentication proxy in front of Prometheus, so that's how we're able to provide some restrictions around the workload so that projects only get access to what they're looking at. Yeah, so now when you come to your cluster, now that everything's deployed, you can see our dashboard for our cluster is now enhanced. So within the Rancher UI, without leaving, you get utilization, load average for all the components, the disk network. You can see, get at our etcd health, Kubernetes components. If we had the logging aggregator deployed, we've also got, we'll collect metrics for that, but I haven't turned that on in this cluster. You can see, now within the UI, without going anywhere, you get a decent set of, you can quickly get a good look at your cluster. But we've also now deployed the stats or the collector for etcd. And now within this cluster level, you can see different things around daemon sets and pick which one, components, pods. Basically all of the health of all the things, or all the metrics that we're able to collect that Rancher is deployed. Then the other fun thing is now our alerts are now also updated so that they're now based on metrics collection. So now we can come and look at this one, we can edit. You can see that this is now based on a Prom SQL query. And we're able to now alert when things are going happening in real time on when things are happening in the cluster. So you can configure notifiers and get alerts based on these events, and have visibility into your whole system here.
Well, Bill, it may be good to take a quick break. There's about 40 questions of all sorts of different things kind of rolling. Is this a good time to sort of pause, or did you want to show something about the
let's
okay, cool.
Pause.
All right, so let's just kind of dive into it. The first question was actually about, there's a couple people asking questions about existing deployments of Prometheus using the catalog app. So historically, we've always had Prometheus in the catalog, and it was as a Helm chart, and it would deploy Prometheus, and then the user was really on their own to configure and operate and run it. So Sebastian said, in that previous one, were we also using the operator, or was that just using kind of a Helm chart without the operator?
I believe that was using the Helm chart. I believe it's using the Helm chart without the operator.
Okay, that was my feeling as well. I wasn't 100% sure though. And so then another question came in, and that was sort of, for people who were using that before, is there a way to move from the current, from an existing implementation to this, or should they really just almost like, kind of upgrade, wipe it out and move to this if they want to take care of anything? There's no upgrade path, right, from a deployed Prometheus?
No, they're disparate systems at that point.
Yeah, that was my guess. And then, a lot of questions are kind of around this new Prometheus, how configurable, customizable, extensible is it compared to go to roll my own? And I think it's a pretty kind of smart question, which is, for example, I think Hari asked, can additional Prometheus modules such as Blackbox or Prom2 teams be integrated? How flexible is the Prom stack from a customization standpoint? So it was a good question. You want to talk about that?
Yeah, I mean, I know we've done some of our own customization of it. I don't think, I mean, it's extensible from, like, I think you can, I don't know how much we're exposing at the beginning about how configured it'll be, but I mean, there are the CRDs for service monitors still that exist, and so you can use the operator there. You can, I think we have our own alerting thing that we're doing, but the Prometheus stack itself, I don't know that you're going to be able to add custom config or kind of custom pieces. I mean, you can add.
It's to the design.
You can,
yeah, fundamentally, in a lot of ways, inside of Rancher, we sort of have two types of things, right? The idea is that everything is native, so we implement Kubernetes natively. Anything that runs in Kubernetes will work, and there's always the option to kind of deploy things and maintain them directly. The tools thing, in a lot of ways, the idea with monitoring and alerting within the tools is to sort of provide a pretty general purpose implementation of the function, like we did with CI/CD, and then something that we can maintain, upgrade, and support for people as they consume it. But if you need to, kind of go and really customize it quite a bit, you're probably better off building your own stack and maintaining that, because we're going to be upgrading the versions of things on a regular basis in the tools. So the tools is a little bit more like a managed service than like a sort of custom implementation of the technology. Like, we're not pulling the normal Prometheus out of the catalog, and you can certainly continue to use that. With tools, we'd like to make it extensible to within reasonable level, but we also, one of the values we're trying to solve with this is upgradability, compatibility with other services, integration. So it needs to also be, it's more like a built-in function and capability than it is like, just an install of Prometheus that you can go and do whatever you want with. Would that sound roughly right to you, Bill, in a way to characterize it?
Yeah, I think, yeah, exactly. And then the way that we're doing it is, using the open source tools and providing the tool itself and letting you use it in a way that makes sense. But it is slightly, the difference between what we're doing and what you would do is just making sure it works within the tenancy model, of projects and namespace scopes, and sort of trying to tease apart those views for users versus owners and operators. And so that's sort of just some of the work that goes into figuring out how to get at certain parts of the data. And then we've talked with other monitoring providers, and specifically to the monitoring one, we've talked to other monitoring providers. Sysdig and Datadog provide a lot of value in addition to just kind of the functionality of like a Prometheus and Grafana. They're pointing out the remote write APIs, and possibly we might have some extension points where if you were running your own stack, you could still get at some of the data that's needed that we would be collecting, so we could fit into your broader monitoring picture. And we can handle the instrumenting.
Yeah, a lot more questions, but I don't want to slow us down too much and keep us moving. One other, I think, high-level question that came up a couple times is when I implement this Prometheus, is it possible to monitor things that are outside of this domain? I think we talked about this briefly before, but if I wanted to, can I attach the Prometheus exporter to something else and point it back to this so it starts to show up in my graphs? Or would you say that this is more configured, more scope to just whatever's running in Rancher?
No, there's ways with the Prometheus operator to monitor things outside of the cluster, and it just involves creating We haven't built a super easy button for it yet, but I think it should be possible. It just involves creating Kubernetes services that point to external things that then can be discovered by the service discovery pieces, the service monitor elements of the operator.
So one other question that sort of a number of people asked was about the implementation of this. So if a lot of people use Rancher and an air gap networks, they also use it without the catalog enabled. So Vincent and Nadir both asked, is there a way to use it, in an air gapped environment? Do they need catalog access to use this, or is there something they can copy down locally to make it all work if they're on air gap?
It should follow the same pattern as what we're doing with our logging Fluentd implementation, where it's part of our system images, and I believe the template to launch this is actually built into Rancher proper. It's not part of the catalog, as far as I know. And so I think it should fall under the kind of in that same bucket and work in the different install modes.
Okay. All right, why don't we keep going and kind of keep going through the demo, and we'll Jason and I will try to answer some more of these questions as they come in.
Yeah, and so this was just kind of the cluster level and kind of what comes out of the box. And so let's take a look at the project level. So again, in my project, if I want to enable monitoring, I come and I enable the Prometheus dashboard. I can set persistent storage, but this gives me my project scoped Grafana. So it does need to be enabled here. Now looking at this, you can see I'm deploying, I got a new workload in my project. So the thing that I thought would be kind of fun is, I can see this now in my workload. I can see that there's the workload metrics as they come online. I'll be able to get access to this. But while this is doing that, why don't I deploy I'm going to deploy Minio using Ingress. I use the Minio YAML generator on their website and made a couple of little tweaks, but there's a little bug in this version where the annotations aren't doing what they're supposed to. But so that's why you're seeing me create a service monitor CRD or CR custom resource directly. And also the monitoring service pieces. So I've just deployed Minio, and can come to the Rancher UI to take a look and see what's really going on there. Oh, our Grafana project is now there, and so I can see my memory usage for my workload, and I can refresh every so much. A little summary detail, CPU usage. But here's my Minio deployment. I've deployed just kind of one Minio pod. I have created a Longhorn volume to back that up, and that's replicated. There's 3 replicas, I think, by default on this Longhorn. This isn't a Longhorn demo, but it's one of the first times I got to play with Longhorn. I was having fun with it, so I just thought I'd call that out. So yeah, now I have my Minio deployment. And so what I did here, is I now have an advanced option on any workload to say, on this port, on this path, scrape these metrics. And so I can expose Prometheus metrics for my application and my deployments now, and these will be discovered by the Rancher deployed services. Ultimately, it ends up being an annotation that you can also use. So you can view edit YAML. You can see the workload is annotated here. And so you can do this as well, and then it should pick up all of the services and create everything in the background. Like I said, there's a bug and it didn't quite work out that way. But now when I come, say I wanted to have my new set of alerting, I can add a new alert group and have a new expression and see here, hopefully not loading yet. Give it a second to scrape. That's going. I can see I've got some this, and then I can always jump off into Grafana and see my Minio deployment from a high level. Again, this is all being scraped at a cluster level at the moment, and so I'm getting access to my data here. And now I can see, that this is just scoped here. I only see deployments that are in my namespaces. Oh, sorry. This is another UX thing. Since I'm a rancher admin, cluster admin, I have visibility into the cluster Grafana by default. So we're going to switch that. If I was a normal project user, I would only see my namespaces. I would not see this complete list. I can sort of show that to you by doing this. See my deployments. This is still all coming up online. Yeah. Okay. So while this is collecting data, I'm going to jump over to the pre-stage version that has more data. Essentially, I've gone through this workflow over here. And so, again, I've got my Minio deployment. And I have my project monitoring. I can jump into that. See deployments. Now I have my Grafana in that namespace, in my default namespace. I have my Minio deployment. And see that this is now just scoped just to my project. And then when I come here and I go to alerts, I can see that all my metrics now that are being collected, all my Minio stats from this application are now being used here. And then when I select that stat, I get a kind of a time view, so I can kind of say, if it's greater than 50,000 bytes for 5 minutes, then shoot me an alert warning or something. And so now I can get actual alerts based on my own application data and get that wired into kind of our system. So as a user, you can just start wiring this stuff up. Okay. And then if I come here, and this is the Minio application I've deployed. And so this is the project level Grafana. I've installed my own Minio dashboard. And when you come in, you can actually, you're accessing this through the Rancher proxy. And so you have to be an authenticated Rancher user to get access to this and in that project or cluster. And once you have access, you can also you can set the admin password on the Minio, on the Grafana, give it persistent storage, and then you can basically edit and create your own custom dashboard. So here I've added Minio, and so this is now scraping. I can see the instances stats, and so if I come to the Minio browser, I'm still logged in, and I can create a bucket, demo time, and then upload a file. Just make this my new Terraform repository. Let's store versions of Terraform up there. And then I can now, hopefully that shows up in the next couple seconds that this happened. You can see the metrics are starting to show that I put some data up onto the cluster. You can see how long it's up and running. You can see all the different stats that come out of kind of Minio. And so this is how you would instrument your own workload as you're adding your own stuff. And just see the live demo just kind of caught up. Everything works so good. But no one was watching. All right, so now I'm signed in apparently. And so I can go here, manage, and I can import new dashboards. I can upload the JSON file. So this is, I went back to the live demo one, and so I'm opening this. I can set my data source to the rancher monitoring, import, and something's not right. Yeah. Anyway, you could import your own dashboard, provided Grafana wasn't arguing with you. But yeah, that's sort of the main feature set at the moment. One thing I forgot to point out is then at the cluster level, you can now also get at your node level metrics for each node from the node exporter as well.
Awesome. Bill, that's I know you've got a ton of questions. You covered a lot in there and went through it pretty quickly. Why don't we kind of dive into some of the questions? Jason, if you want to,
sure.
you can answer some as well as we're going. We'll try to get through these, and feel free to ask more questions, everyone. I'll try to answer. We'll try to answer some out loud as well. So I'm going to start with a couple that I think are sort of broader questions. One was kind of real simple. David just asked if you could provide the Minio YAML that you're using. Do you know where that's located? Is that in how did you generate that?
Minio's website has a Kubernetes YAML generator. The things that I tweaked was just adding secrets and pulling the envars from secrets for the access key and secret key. And then I added an ingress instead of using their load balance service port.
Awesome. So there are a couple of questions I think were like about the deployments. We'll try to group these prep questions into things about the deployment and versus things about the implementation, and then the sort of usage of Prometheus. But from a deployment perspective, Eugene asked a good question. And there were a couple questions about, tied to this a little bit, which is, what is the storage requirement on the back end for Prometheus? For example, he said, what happens if I set up without persistent volume? Does historic data disappear if the clusters are rebooted? Do you want to maybe talk a little bit about, what you need to have in place before you launch this to persist the data and how it's connected?
Yeah. So by default, with no persistent storage, if you lose the Prometheus kind of pod node, you lose the data that was associated with it, the historical data. All of the configuration lives, external to it, and so when it came back online, you would just have no historical data and scraping it. If you add a persistent volume, then you get basically that data comes back when the pod comes back by hopefully the volume getting reattached.
Awesome.
Sizing wise, I think Prometheus docs provide a pretty good insight there, and the documentation for the feature still has to come, and that can definitely be something we recommend in there.
And kind of to your point about the config being saved, Hugo asked if can we deploy and save dashboards on this Grafana? Are they stored on config maps that are overwritten every time there's a new deployment or upgrade of the Prometheus implementation? Like how persistent is the configuration of the Grafana as I build these different dashboards or modify them?
So the way that I've done it here, and I need to dig in it a little bit more with the engineering team. There is a config map, but it looks like when I was setting up for this, when you add a dashboard through the config map just by putting the JSON as a data blob in there, it did not get added. So to make sure that I had something to show in the event that something failed between setting this up and now, I went with the persistent volume for the Grafana. And so that should be writing to the disk and have access to it that way. But I gotta circle back with the engineering team, and we'll document, how that's supposed to ultimately get worked out, whether we're going to go the config map route or a persistent volume route.
Another question was from was about, again, if I've already deployed Prometheus and I have built out my functions, Peter wanted to know if you could import those from an already deployed Prometheus system.
No.
Sorry, Bill, you broke up.
No, not at the moment. It's kind of a standalone thing. I mean.
Okay, so if I wanted to sort of import those type of things, I'm probably, we haven't exposed that much of it yet for people to kind of customize or expose a lot of the
right.
import functionality. Okay, there's another question about the node exporter. So Vincent said, is the pod version of the node exporter for Prometheus inferior to the node exporter installed directly on the host itself, or is there no difference? Trying to look at that.
I mean, we're deploying the containerized version of the node exporter daemon set, and I think it just, if I understand what it's doing, it's stripping away all the namespaces and just sharing it and running almost, the same as the host. I think it runs PID namespace for the host, or PID namespace of the host, net host. It for all intents and purposes, it's trying to get as close to the host as possible. And that's so it can get visibility to the host level stats.
Great. And then two questions about upgrade. Nandish and Nadir. Nandish asked, how would this Prometheus Grafana instance be upgraded when there's a new release for Prometheus Grafana? Do we have to upgrade the whole Kubernetes cluster, or can we just upgrade these components? So is it kind of all about a full Rancher upgrade or just the component upgrades?
I believe it will be as part of the Rancher upgrade process.
Okay. And then how do you manage upgrade? Would you be managing the upgrades then from the operator, the Rancher catalog, or it would actually be part of just upgrading to the latest version of Rancher would automatically upgrade you to the new versions of these services?
It would be done the same way we handle logging, and I'm not 100% on what that is at the moment. I'd have to circle back with the engineering team. Okay.
There was a couple other questions. One of them was, and Tyler asked, are we able to configure Grafana in a similar way as a standalone Grafana, for example, with AD integration? Could I plug that in, or does Rancher already, through its AD integration of all of Rancher, control the auth to the Grafana piece. So my AD integration is automatically, kind of controlled by the Rancher auth proxy. So how does sort of the multi-tenancy and the integration with things like AD work with Grafana in this case?
So at the moment, you have access to Grafana based on your authentication to Rancher. So you can only get access to the Grafana instances that you have in projects that you have access to, or clusters that you have access to. Right now, the Grafana is only running in sort of, like a read-only view versus like as a normal user, or you saw me log in as the admin in order to update and change the configuration of it. Right now, when it comes up, it has the default admin password. You have to set that to something else. And it is sort of decoupled, but there's only that admin user there. And so that, and depending kind of on the earlier question, how we end up addressing and what the limitations are, how to add dashboards. If it becomes kind of a config map thing, then really Grafana would be updated external to itself, and you wouldn't really have a need to log directly into Grafana. It would just be controlled by access to the project.
So that kind of gets to Sanjeev and Eugene. Kind of asked sort of similar questions. Sanjeev said, the Grafana here seems to be a single instance with multiple namespaces, and projects can share and view in a way that's isolated from each other. So are we not using a separate Grafana per namespace? He was a little bit unclear. Is there one Grafana for the whole cluster? Is there a Grafana implementation for each namespace or each project? And that was Eugene's question. Was kind of something like that. He said, is there a separate Prometheus instance in each namespace? Is it possible to run a single Prometheus instance for the entire Rancher server or the entire Kubernetes cluster? Do you want to maybe just kind of outline sort of how multiple dependency is being done? And because I think it's a little bit unclear now, maybe now that people have seen it.
Yeah, so there is one Prometheus running at the cluster level right now, and that is going to be shifting such that there will be a Prometheus at the cluster level and a Prometheus at the project level that gets deployed. Today, there is a Grafana instance at the cluster level and at the project level. What is a little confusing at the moment is there was a design decision that I think we are reversing, is because I'm a Rancher admin right now, when I was demoing, it just, whenever I click a Grafana link, it automatically just takes me to the centralized Grafana instance. We're changing that behavior so that when you're in the project, you'll always go to the project level one, and then if you want to go to the cluster level one, you go to the system project to get access to it, or from the cluster dashboard, the quick links from there. And so it's really it's running at both the cluster and the project scope. And so part of that kind of goes back to some of the scaling things, is just how big do we want to make a single basket at a cluster level. We're still going back and forth internally just on the final design of, are we going to provide, are we still going to get the cluster level metric or the cluster stats even for the project namespace directly from the centralized cluster one, or are we going to double scrape and scrape the system metrics into the project Prometheus? We haven't, or make that a decision that the user can make for themselves, depending kind of on their storage availability needs and just sort of their requirements. So that is kind of how that gets deployed, if that makes sense.
Awesome. Yeah, I think that makes a lot of sense. So there's another couple of questions. Eugene asked if the Prometheus instance only monitored the cluster that it was deployed in, or does it monitor Rancher itself? And then someone else asked, if I deploy all this in the cluster and I lose the cluster, obviously my monitoring is sort of dependent on, I lose all my monitoring, which would have helped me
Yeah.
look at something. So do you
we
want
have
to
to do
talk a little bit about global and local and sort of how things can be done in a way that's prepared, kind of saves them in case I lose my cluster or things go down?
Yeah, kind of at this pass, it is cluster level monitoring and ranchers managing multiple clusters. We need to create a monitor of monitors, and also as part of that, it's not there today. It'll be a next iteration feature. But a monitor of monitors, where we would run a more centralized one that then would monitor, have a high-level roll-up view of all the different clusters that are running and attached to the rancher instance, along with the rancher workload. If you are in an HA setup, you do have local cluster access, and so you could use these tools to deploy into the local cluster. We haven't instrumented rancher as a deployment yet, to scrape metrics for that. But you could monitor the cluster technically. With that, and in a lot of circumstances, that could work out. But yeah, that is sort of a current limitation, that if the cluster completely dropped off the map, all the monitoring of that cluster just went with it, and the alerts from that cluster also. So there's just a next level thing is to get kind of the monitor of monitors.
Cool.
And alerting on that.
Awesome. A question from Raj. He asked, what is the impact of Prometheus monitoring in terms of overhead? We talked about storage requirements, but what about just how much this consumes the cluster's RAM, CPU, and other resources?
It depends on the workloads that it's scraping and how many metrics and a number of factors, scale-wise. Doing nothing. It can be terribly busy doing nothing. Depends on how much it's going to have going on. And what the workload is that you're putting on it, and how many metrics you're collecting, and we still have to run it through our own set of internal benchmarks to see what some good recommendations would be for various cluster sizes, assuming kind of some sane defaults.
Raj kind of followed that question up and just asked if there were any best practices or recommendations on Prometheus long-term storage and downsampling.
I'm not familiar with. I don't have any right now to recommend now.
Okay. Okay, we're just wrapping a couple more questions. There was one that Hari asked. He said, if a Kubernetes project exposes dynamic endpoints like load balancer endpoints, will the Prom operator be able to auto-discover these endpoints? So does that also get kind of picked up?
Yeah, so we do pick up the ingress metrics as far as I know. That is yeah, I mean, so our basic, we're working on wiring up the Nginx ingress controller so that that is deployed, and then you'll be able to get at its stats and metrics, and so we'll be able to let's see, its CPU runs like a, but yeah, I don't know where it is off the top of my head. But yeah, the goal is before the feature ships that the ingress controller will have kind of its own set of dashboards along with its the ability to kind of to get it to different paths as best we can get there and sort of get high level aggregate stats of the metrics of basic the ingress like HTTP status codes and stuff like that, error rates. And wire that up. The other thing that hasn't been implemented yet that we're looking into doing is also, these metrics should be exposed through the kind of custom metrics endpoint so that you could use them with the horizontal pod autoscaler. It's just, and so we're working to kind of working through as many of the touch points as we can, kind of going towards the 2.2 final release.
Okay. A couple more questions. Jan Gottschalk asked, will you add support for Grafana Loki too? Do you know if we're working on that?
I don't know at the moment. It's something we'd have to look into.
Okay. Another one, Vladimir said, is it possible to monitor and set an alarm for the Rancher components like etcd and control plane down? Do you want to dive into that? I don't know if he means the Kubernetes, etcd, and control plane services in the cluster. I think that may be what he means.
Yeah, so we do tie into that, and so but it depends on who provisioned the cluster and what we have access to, by how easy that gets wired up. So at the cluster level, we have the alert level here, and so there's a set of alerts. If it's unavailable, has no leader, and I think we got key space metrics that are now being monitored, and also if the leader keeps changing, excuse me, you can get notifications on that. But etcd is being scraped in this cluster, and so you have access to all of that. This is kind of our first path up the metrics. There's a pretty good, we're going to be going through kind of what, there's a pretty good monitoring set of docs on etcd documentation to make sure that we're covering kind of all alerts that they're sort of flagging and things to watch as well. So, so all the components are being scraped so that we have access to. As I kind of showed here, your etcd metrics are now here and sort of shown here. They're also available in Grafana. The cluster metrics overall, kind of just that. And then the Kubernetes system components, the API server, the scheduler if it's having issues, ingress controller, the number of connections on the ingress controller. And then here's kind of here are the ingress stats. So here's a table of kind of what's being hit in the past and it's general response time.
There was another question, Bill, and he was saying, it was from Miklos. He says, is there a way to deploy an HA Prometheus setup with the operator? For example, deploying 2 Prometheus servers with exactly the same targets.
I don't think out of the box we have that configuration. So no, we wouldn't have that. So you would have what we're going to work through on upgrade is, well, we still have to figure out how we're going to do that. I think we'll have a momentary blip during that upgrade process. So I think there'll be some fine-grained control on when that needs to get upgraded. But yeah, there's only one.
All right. Well, that was the last question. Bill, unless there's anything else you wanted to go over, I think this was great. You covered a ton of stuff in here. I know Jason answered a lot of questions, and I answered a lot of questions. So hopefully we covered most of your questions. If you have more, fire them away. But with that, I'll thank you and Jason for covering all this. I'm just going to go through a couple more things before we wrap up and talk about a few other things. So can everyone still see my screen? If you're really new to Rancher and you haven't gotten started, we have really clear docs on how to get set up. I know there were some questions about what's the difference between Rancher and RKE. Rancher is really the management platform. RKE is the installer for Kubernetes. They're two separate open source projects. You can get a really good detailed information about all of them just going to rancher.com/docs, and you'll start to see there. Docs.rancher.com takes you there as well. The Slack channel is always great. Another great place to get this information, especially on things like our roadmap, is all on GitHub. So if you haven't already, please come over to GitHub. Give us a star. I think this picture's a lot of date. We just passed 10,000 stars a couple of weeks ago. So thanks to all of you who've shown us the love. The one thing we would definitely love is more suggestions and issues that are kind of focused on how to make these new services better. So if you have ideas or ways that you think we can improve it, by all means, fire up an issue. We do our best to get to them. Obviously, you can see we get tons of these, so there's a lot of input. The Slack channel is also a great place to find all of us. I'm on there, Bill's on there, JVB's on there. So if you have a question afterwards, you can hit us up on the Slack channel. And with that, I will wish you all a fantastic end to 2018. It has been awesome speaking to so many of you, meeting so many of you in person at different events this year. It's been an incredible year for us as we introduced Rancher 2.0 and seen it just become incredibly popular. So thank you all for your support and for your participation in our community. If there's anything any of us can do, please reach out. We're always hiring, so we're looking for people in every country around the world. I think we've just passed over 100 employees and we're growing really fast. So if you're interested in working on Rancher as an engineer, you're interested in being an evangelist, you're interested in working as a field engineer or anything, please reach out and introduce yourself to us. I'm just Shannon at rancher.com, and you can find me there. With that, if you have any other questions, feel free to put them into the questions box. We'll try to answer them offline. And hope everyone has wonderful holidays, and we'll see you in January with our next big meetup. So have a great day, everyone. Thanks, Bill. Thanks, Jason.
Thank you all.